Alright, so now we are looking at 4.4, properties of logarithms. The homework for this one will have a worksheet, so no book assignment that we have to write down. Um, if you haven't gotten that, make sure you get that before you leave today. So we're talking about properties, product property of logarithms. So in words, the logarithm of a product is equal to the sum of the logarithms of its factors. Alright, so we have sum and factors are kind of combining multiplication and addition. So here's an example. Log base 3 of 1,000 can be rewritten as log base 3 of 10 times 100. And since we're multiplying these two things, they can be broken up into two separate logarithms being added together. Algebraically, we can write that like this. Log base b of m times n, so two different things, is equal to log base b of m, and I'm not going to be able to fit this exactly here, but plus log base b of n. So the multiplication becomes the logarithm of two things being multiplied becomes two different logarithms, both the same base. In this case, we're calling it b, and we are adding those two logarithms. All right, let's take a look at trying some of these out. So we're going to express each of these as a single logarithm and simplify if possible. So here's log base 4 of 2 plus log base 4 of 32. All right, they're being added, so we can, and they have the same base of 4, so we can combine these. Log base 4 of 2 times 32. We're going to be able to simplify most of these. So that's going to be log base 4 of 64. All right. And now, okay, what does this mean? Okay, well, if you remember, that means we have a base of 4, and it's being raised to some power we don't know, called x, and that's equal to 64. All right, so what value is that? In this case, that's 3. It worked out perfectly. X is equal to 3. All right, sweet. Okay, let's try another. So this time we have both bases of 5. Again, addition, we can multiply, so log base 5 of 625 times 25. And this is going to be some large value, and it ends up being, when you multiply those two big numbers, 15,625. Right, now to be able to try to simplify that, that means we have a base of 5 raised to some power x, and that should equal 15,625. All right, now you might not know this one right off your head. When I went through these notes earlier, I just did guess and check, and x ends up equaling 6. All right. Okay, next one. So we've got log base 1/3. So log base of 1/3. So you can use parentheses there for the base to kind of keep it separate, and then of 27 times 1/9. So kind of a hard one to write here with all these fractions. Okay, so let's multiply 27 times 1/9, so that's going to be log base 1/3 of, that becomes 3. So what this now means is a base of 1/3, all being raised to the power of x, must be equal to this 3. What's our x value? Well, it becomes a fraction into a whole number. Remember, this is like 3. You can think of this as 3 over 1. So the fraction's being flipped, and the number's not changing at all. So flip means negative value, and since the number didn't change, it's going to be 1. So negative 1 is our exponent. You can double check that by entering that in the calculator, 1/3 to the negative first power, and that should equal 3. As long as you use, make sure if you're going to put that in your calculator, make sure you use parentheses. Alright, so that's the product property of logarithms. Now for the quotient property of logarithms. Alright, so in words, the logarithm of quotient is the logarithm of the dividend minus the logarithm of the divisor. So now we're going from quotient and subtraction. Okay, so here's an example. Log base 5 of 16 divided by 2 is equal to log base 5 of 16 minus log base 5 of 2. Notice how one logarithm becomes two logarithms. Same base, the division becomes a subtraction. So in algebra terms, that'd be log base b of m divided by n. And that's going to be broken up into log base b of m minus log base b of n. So we're subtracting. Okay. Let's try some of these. So this first guy, log base 2, since they both are log base 2, we can combine these into one single logarithm, and it's going to be 32 divided by 4. Well, 32 divided by 4 is 8. And the logarithm of base 2 to 8, so that is a base of 2. We're looking for the exponent, and it's going to equal 8. So 2 to what power equals 8? You might know this one off the top of your head, which is 3. 2 to the third power equals 8. Okay? Alright, this next one, log base 7 of 49 minus 7, or divided by 7, and we combine them. So that simplifies the log base 7 of, well, 49 divided by 7 is 7. And this one, if you remember our rules from before, this just becomes 1. To show all the work, though, I'll show it. So this base of 7 raised to some power must equal 7. And, of course, the only number that works there is 1. Alright, one more here. So log base 5 of 100 divided by 4. 100 divided by 4 is 25. Alright, so this means 5, the base of 5 raised to some power must equal 25. And that's when we should know x is equal to 2. Because 5 squared is equal to 25. Alright, the third and final property that we're going to talk about is called the power property of logarithms. Let's take a look at the power property of logarithms. So in words, the logarithm of a power is the product of the exponent and the logarithm of the base. So now we're combining powers and product. So here's an example log. This is a common logarithm, you can tell, because there's no base written in. So the common log of 10 to the third power. Well, that's the same thing as 10 times 10 times 10. You can break that up with our old property. It's not really that old, it was just a few minutes ago. The product property, if we see multiplication, we can split that up into additions. And since there's 3 of them, well, that's you can put a 3 in front and just write the common logarithm of 10 just once. So if you kind of see how we can maybe go from this top step to this bottom step, the shortcut is that you take that exponent and bring it out in front. Alright, and we always like shortcuts in math, so that'll be nice. Let's take a look at that algebraically. So log base b of a to some power p. So since it's got that power, we can write that as a multiplication out in front. So p times log base b of a. Right, So notice now that the power of p is written as a multiplication out in front. It's no longer a power. All right, so let's try this out. So first off, we can write this, bring this 2 out in front. So 2 times log base 3 of 81. All right, now let's look at this logarithm and see if we can actually simplify that. So that would be 3 to some power is equal to 81. And the power that works there is 4. Now that's not our final answer because we want to do 2 times that. So that's the same thing as 2 times 4, which of course is 8. Our final answer. So I kind of, here, maybe I'll use some different colors here. So this stuff in green I got from over here. Okay. So this next one, bring that 3 out in front. So it'd be 3 times log base 5 of 1/5. All right. So let's focus on this. Can we simplify the stuff in there? So that'd be 5 to some power is equal to 1/5. All right, so what power is going to make 5 1/5? That's got to be a -1. Negative because it's flipped, and 1 because it's still a 5. If it was like 1 over 25, then our exponent would be -2. Anyway, so then now this becomes 3 times -1, which is -3. Okay. One more here. Oh, well, a couple more, I guess. But okay, this next one. So this is equal to 4 times log of 10. Now that's a common logarithm, so that means it has base 10. Let's look at that logarithm. Can we simplify it into a value? So that's the same thing as 10 raised to some power x is equal to 10. All right, because there's that hidden 10 right in there as a base. That's an easy one. X is just equal to 1. So then that's equivalent to 4 times 1, which is just 4. Okay, let's take a look at this next one. So the 2 can be brought out in front, so that's equivalent to 2 times log base 5 of 25. Let's focus on that logarithm. Can we simplify that? Now this one might be one that we've seen before, or you can maybe start to do these mentally a little bit. So mentally you might think, okay, 5 to some power must equal 25, and that's 2. So this is just going to become 2 times 2, which is 4. Now let's try this next one. Bring the 5 out in front. 5 times log base 2 of 1/2. Right? Focusing on that logarithm. Maybe let's try this one mentally as well. So 2 to some power must equal 1/2. So it's a fraction. So that gives us a clue that it's going to be negative. So 5 times negative. So that 2 got, this base of 2 got flipped. And the denominator is still 2, so it didn't get raised to a power of anything, so it's just -1. And that's going to be -5. Now, if you don't like that, doing that mentally like I did on those last two, of course you can show your work like I showed here, you know, finding the logarithms by writing it as an exponential function and simplifying that. Alright, so that is the 3 main properties. Now we do have some other properties that we can use to help us simplify things quickly. These are inverse properties. kind of talked about inverses before. If you remember, an inverse is something that undoes another operation. So here we have some things that undo. So notice we have log base b of a b, another base b raised to a power of x. So when there's two base b's there, log base b of a base b raised to a power of x, it's kind of like the log base b, or sorry, yeah, the log base b and the base b cancel, and we're only left with the power of x. So let's just look at an example. So if we have like log base 7 of 7 to the 8th power. All right, so since we see log 7 and a base of 7, we can cancel those, and all that we're left with is 8. I sometimes even like canceling these like this when I'm doing my work. But yeah, log base 7 and a base of 7 cancel. So that same idea applies when we have an exponent. So a base of b with an exponent of log base b. So again, we have two bases of b. Now they're written a little bit different than what we saw in the one above it, but the same idea applies. Two bases put together through an exponential equation, they're going to cancel, and you're just left with that x in this case. So, for example, if we add a base of 3 raised to a power of log base 3, now it doesn't really matter what I put in here, but it's going to be the answer. So let's say like 28. So log 3 raised to the power of log base 3 of 28. The base 3 and the log base 3 are going to cancel, and we're left with that 28. So the way you would show the canceling, those two things cancel. Now, sometimes they're not that obvious. Sometimes we have to do a little more work, but yeah, that is how you can do inverse. So let's take a look at part A here in example 4. So this one's one such that's that easy. So I see a log base 8 and then a base of 8 raised to some power, 3x plus 1. Since I see a log base 8 and a base of 8, I can just cancel those out, and all I'm left with is 3x plus 1. All right, part B is not as obvious because there's no base of 5 here. There's a base of 5 on the logarithm, but this 125 is not an exponent. It's not 5 to a power. But 125 can be rewritten as 5 to a power. So this is where you have to be a little creative and think. Well, okay, so this would be log base 5. Now 125 can be rewritten as 5 to the 3rd power. After we rewrite it that way, notice that we have two bases of 5. Log base 5 and a base 5 here. Therefore, our answer is 3. I guess I'll circle my answer over here too. All right, and this next one, we've got 2 as a base raised to the power of log base 2 of 27. So since we have two bases of 2, exponential base of 2 and a log base 2, they cancel, and we're left with just that exponent, which is 27. All right, nice. Okay, so the next thing is the change of base formula. So this formula will allow us to find the logarithm of anything. Even if it doesn't work out nicely, we can get decimal answers. This is going to be really nice. Some calculators already allow you to put any type of base in, but not all calculators do. So this will help any calculator solve a logarithm. Anyway, so the way it works is if you're trying to find log base b of x, you can rewrite it as log base some base a. It's arbitrary what it is, of the x, and that must go on top, and then divided by log base a of b, and that b must go on the bottom. You think, the base, because this is the base, must go on the bottom in your fraction there. So an example would be like log base 17 of 348, let's just say. Okay. Now, one of the easiest bases that we can use if we're using a calculator is the common logarithm. Because if you have a calculator right in front of you, it just says log. Actually, I'll show you right here. Let's see, log right here. It's to the left of the 7 on my calculator. That's the common logarithm because, I'll clear everything else out. Because there's no base written by it. It just says log. Okay? So it's readily available, the common logarithm. So we'll use common log of, well, the 348 goes on top, and then the common logarithm again of 17. And we can just punch that into our calculator, and we would get approximately 2.07. And I can show how I would type that into my calculator here. So log of 348 in my parentheses divided by log of 17 in my parentheses, enter, and it gives me this fairly long decimal. I rounded it up to the nearest hundredths place. All right. Okay, so let's practice with changing the base of the logarithm. Okay, so for this part A, we can change that to log of the 8 divided by log of the 4. Enter that into our calculator, and this one is not an approximate answer, it's exactly 1.5. Now at first you might be looking at B and thinking that's a typo, but actually I purposely put that second one in there because there's another logarithm button on our calculator that we'll talk a little more about later, but it's this ln button right here. It's right below logarithm, at least on the TI-84 it is. Might be different for other ones. But this has a base, it's a base of E. E is a number that we'll talk about later. Let's not worry too much about that, but it's just another way that we can do the change of base formula. So, for example, we could use, instead of log, we could, the common logarithm with base 10, we could do this natural logarithm ln of 8 divided by ln of 4. It is a logarithm, even though it doesn't say log. And I use a cursive L whenever I write the natural logarithm because if you put manuscript L, it looks like a 1, I feel. ln of 8. It looks like 1n. I don't know. I just don't like the look of it. So I put a cursive. Anyway, punch that in your calculator, and I'll show you it does still work. ln of 8. Get rid of that. ln of 8 divided by ln of 4. Alright, you get 1.5, and if you don't believe me, I'll type in this one as well. So the thing is you just couldn't mix them, right? You couldn't do like log 8 divided by natural log of 4. This will not give us 1.5. I'm not sure what it's going to give us. Yeah, something else. So you can't mix the types of logarithms. Yeah, it's just your call which one you want to use. Sometimes it's nicer to do the natural logarithm because ln is a little bit less to write than log. But it's not a big difference. Oh, anyway, yeah, that equals 1.5. All right, part C. So we can do, I'll go back to common logarithm for this one. So log of 27 divided by log of 9. And that actually also equals 1.5. And this next one is, let's do natural log again. Natural log of 159 divided by natural log of 3. And that actually is an approximate answer of 4.61 rounded to the nearest hundredths place. We're going to skip the example 6 for now. Oh, teacher, what are some properties of logs? What is this student going to say? They're round, they have bark, and they come from trees. Yep, that is what a log is, but that's not the type of logs we're talking about here. So logarithms. Yeah, our logs have rhythm. Anyway, oh yeah, skip. Yay, alright. Okay, condensing the logarithmic expression. So we're going to put all this different information we have together and condense and stuff. So that means we want to make them into one logarithm if possible. Alright, so same base of 4. We have subtraction. So remember, subtraction means you can rewrite that as division. So that would be 7 on top divided by 10. And there you go. And we could use our calculator to calculate that, but for now we're just going to leave it that way. Just condensing it. Natural log 12 minus natural log 4. So that would be natural log of 12 divided by 4. Well, now 12 divided by 4 does simplify pretty easily. That's natural log of 3. Okay. This next one. Oh boy. Alright. 6 natural log x plus 4 natural log y. So remember, if there's a number out in front, before that was a power being brought out in front, we can bring a number being multiplied out in front as a power on what's inside the logarithm. So this would then become natural log of x to the 6th plus natural log of y to the 4th. And since they both are natural logs, the same base, we can multiply the stuff on the inside. So natural log of x to the 6th times y to the 4th. From that old rule that we were talking about. Part D is similar. So that base, or that power of, that's 2 is going to become a power. So it'd be log of x squared plus log of 11. Those are common logarithms. And since they're adding, we can multiply them on the inside. I like to put the 11 first. That's the standard way that we see it written. Okay. Alright, they can get kind of tricky sometimes with subtraction. So 6 being raised as a power, 4 being raised as a power. So it's going to be natural log of 2 to the 6th minus natural log of y to the 4th. Okay, we can write that as a division because there's subtraction there. And 2 to the 6th simplifies to 64. So that's 64 over y to the 4th. Alright, this next one's got 3. But be careful because we have log, log, and natural log. So we actually can't combine that last one with the other 2. So let's see. Let's see if we can do 2 steps in one. So this is going to be raised as a power, raised as a power. 2 to the 5th that we would get there is 2 to the 5th is 32. So that's going to be log of 32 times by, this would become x to the 7th, and it's times because of the addition there. And then that's just plus, and that 4 becomes a power on this natural log like so. We can't combine those because the log, the common log and the natural log are not the same type of logs. They don't have the same base. All right. Now let's look at expanding. So taking a single logarithm and expanding it into multiple logarithms. So this first one, we have log base 3 of 4 times x. So we can break that up. That's since multiplication, we can break that up into two things, two logarithms, and with addition in between. Like so. Part B is just like that one, so I'm going to skip B. You can try that on your own if you'd like later. Part C. So this guy, same kind of idea as part A, but there's also going to be a power. So let's see what that's going to do. So log of 10 plus log of x to the 5th. But the power of 5 can be brought out in front of that second one. So that'd be log 10 plus 5 times log x. That would be the answer for that. Again, part D is very similar to that one. So I'm not going to get into that one. All right. Part E. So this one we have a division. So that means subtraction is going to be involved. So part E is going to be a tricky one. So log base 5 of x minus log base 5 of 3y. But look at that second one. It's got a multiplication in it, so that second one can be broken up into an addition. So it's log base 5 of x. And now be careful because you're subtracting this whole thing. So we're subtracting, in parentheses, log base 5 of 3 plus log base 5 of y. And then, if we don't want those parentheses, we can distribute that negative. And then that would be log base 5 of x minus log base 5 of 3 minus log base 5 of y. And F's slightly different than E, so I'll show that one. So we've got, this time we have the multiplication on the front end. So that's going to be log base 7 of 6 plus, because of the multiplication, and I'm going to actually bring that 2 out in front of this next one. So 2 times log base 7 of x, and then minus, because of the division, pull that 4 out in front, 4 log base 7, if I can fit it in there, and then y. Yeah, that's a y there. All right. Okay, so the rest of this time should be used for homework. All right. I would like, for Wednesday, we are going to have some work time, but I do expect that at minimum, everyone should have 2 homework assignments done of the 4.1 through 4.4. So please have 2 homework assignments done or more by tomorrow, Wednesday. All right, see you guys tomorrow.